All right. So third day of 10-1 and the last day of 10-1. And probably the most important one to be here for the notes. Obviously you could listen to them, but I think it's very helpful to be here. So here it says determine the measure of one interior and one exterior for each regular polygon. It does have to be regular because remember we just said from the assignment that regular means all the angles are the same and all the sides are the same. And that's the only reason we can actually find it. So letter A says a 22-gon. So how many sides does a 22-gon have? Well, 22. How many angles does it have? Well, 22. No big deal. Now I'm going to show you basically a couple ways you could do this if you wanted to. Right? And after these first couple, I think you're probably going to go along with my method of doing this because it's a lot quicker. Now what the book really wants you to do is to go back to that formula right there. Because that formula right there tells you the sum of the interior, which means all of them. Are we expecting that to be a pretty big number for a 22-gon? Is the sum going to be pretty big? Yeah, it's going to be a lot, right? And so what you would do then is just put 22 in place of n minus 2, and then take that times 180, right? Well, what is 22 minus 2? That's pretty simple. That's just 20, no big deal there, which I then have to take times 180, 3,600. Is that the answer to the question? No, because the question says one interior and one exterior. That's all of the interior. Agreed? That's all, how many of them again? All 22 angles added up. So if I want just one, and again, if it's a regular polygon, can we agree all 22 better be the same number? Then all we have to do is take this total and divide it by 22. Okay? And so that's why some people say to find just one, you can just divide by n then. Okay, that's what some people say to find one interior, and that works fairly well. And what is 3,600 divided by 22? Nearest tenth. 163.6? So do you agree that is one way we could find one interior? Okay. I'm going to show you a way that we could find one exterior. So we did all this work over here to get 3,600 to find the total of the interior, right? Well, what's the total of the exterior? 360, very good. It was a weekend, so I was just checking there. Because does it matter? If it's convex, does it really matter how many sides it has? No, the total is going to be 360, which then I will divide by 22. And it should be no surprise here as to what you get for an answer rounded to the nearest tenth. 16.4. So this would be the one in blue here is your one interior, the one in green is your one exterior. Why did I say it should be no surprise that that ended up being 16.4? Does anybody remember from day one notes? There's a relationship between these two numbers. What is yeah, they better equal 180, right? Aren't they supposed to be a linear pair? All right, just think of, say, obviously this isn't the pentagon that we're dealing with, but if I took one exterior and one interior, shouldn't they add up to 180? And that should happen on all of them. So does what I showed you here, does this work? Yeah, but here's how I actually will do the problems. When I see these problems, all I do, I don't do all this work, even though the book really wants me to. I don't do that. I say, okay, let's find one exterior. You know why? Because guess what number is the same every single time? 360 is the sum of the exterior. Divide by how many angles? You agree that's 16.4? It still is, isn't it? And then all you have to do to find one interior is take 180 minus 16.4. Do you get the same thing we had there before? Yeah, and what is it? It's 163.6. Do you think that's a little quicker? Yeah. Is there anything wrong with this formula up there? No. But this way's a lot quicker. So how about an 18-gon? Is the sum of the exterior still going to be 360? This is letter B now. Yeah, the sum of the exterior is 360. No big deal. Should I divide that by, well, how many angles are we going to have? 18. Now, am I finding one exterior right now or one interior? Which one am I finding? I'm finding one exterior, right? And what do we get for that one? 20, a little bit better number, right? I don't think we even have to round that time, right? So if that's the exterior angle right there, What's one interior? 160. Again, could you have done that formula we did over there in blue at the beginning? Yeah, it still would have worked. It still would have given you 160. Okay, but I think that's way quicker. One exterior, one interior, there they are. Okay. Whenever possible, I go to exterior because you know it's 360 for a total. Okay. Any questions on those first couple? So what if I give you an exterior angle of a regular polygon? Again, regular means all the angles and all the sides are the same. Determine the number of sides. Uh-oh, turned it around on you. But it's saying that one exterior angle is 60 degrees. It might be helpful to know what an interior angle then is. If that's the exterior, what's the interior? 120. Okay, that might be helpful. But the nice thing is I stick to exterior as much as possible because you know the total of all the exterior is 360. If I divide that by just one of the angles, will that tell me how many angles I have? And that'll also tell me how many sides I have, because the number of sides and number of angles are the same. So 360 divided by 60 is 6. So in other words, this is a what? Hexagon. Okay? 6 sides, or you could say hexagon. Now, if it's a 24-degree angle, do you expect this to have more sides or fewer? It's an interesting question to ask, making you think a little bit backwards. It's making that exterior angle a little bit smaller. But we still know the total's 360, isn't it? So if the total is still 360, divide that by 24, are we going to have fewer sides or more? Well, we're going to have more. And how many sides does this one have? 15? Do we have a name for that one? No, we don't. I'm sure there is one, but we would just call it a 15. So, any questions so far? You notice, what have I been doing so far? I've been sticking to those exterior angles. Ooh, I gave you an interior this time. It's a regular polygon, though. Determine the number of sides. Well, isn't that the same number we started with last time, 60? Oh, yeah, look at that, 60 and 60. So if 60 is the interior, yes, you could do this, go in that big, long formula. But what was my suggestion? Always try and use exterior if you can. Why? Because the total is 360. There's no work to be done. But that is not an exterior there. I've given you an interior, so 60 degrees, so that does make it more difficult. But can you figure out the exterior rather easily? Yeah, if 60 is the interior, what's the exterior? It's 120. Remember, they have to add up to be 180, right? And so if 120 degrees is your exterior, well, take 360, which is all the exteriors, and divide by one of them. Because remember, they all have to be the same. Divide by one of them, and what are we looking at? A triangle. Very good. And a very particular type of triangle. Equilateral and equal angular. Yep. So it is a triangle, or it has 3 sides. So how about 162 for the interior? Is the exterior going to be very big? No, the exterior doesn't have a whole lot of room, does it? What is that exterior then? 18. So if that exterior angle is really small, do you expect more sides or fewer? Well, probably a lot more, because can you get less than a triangle? No. All right, so you better have just said more just on principle. Okay, so 360 degrees. Divide it by 18 degrees. The degrees would cancel. I hope you see that. And so that will tell us how many sides. It's probably quite a few sides. 20. So in other words, 20 sides. Or if you had to call it something, a 20-gon. Okay. So once again, I wasn't kidding you when I said go to exterior. You see how easy these are? Go to exterior whenever possible. And has there been any case so far that I really couldn't? No. Okay, there has not been a case yet. Any questions?